Outside our galaxy.
In 1957, the Soviet Union shocked the world, and the United States in particular, by launching the first man-made satellite. And this was a result of tens of thousands of man-years of work, of 10 or hundreds of millions of rubles, of a huge bit of organization, many scientists, but they did it. I'm joined here by Dr. Paul Dare, who wants people to launch a satellite on a shoestring. Now, Paul, you look a perfectly reasonable, sane person. What's this all about?
So the N Prize is a challenge to basement engineers and garden shed boffins around the world to be the first person to launch an amateur satellite into orbit around the Earth.
I mean, it sounds marvelous, and I suppose if I was younger, I would love to have a go. But have you actually come across people who are prepared to do this?
We have. Instead, we're still open for registration if you would like to have a go, if you change your mind. The competition's been running since 2008, and so far we have 24 teams signed up from all around the world. We have about a dozen teams in the United States. We also have 4 teams from the United Kingdom, 3 from New Zealand, oddly enough, and also teams from Canada, Australia, South Africa, Ghana, mainland Europe. It's a very international competition at the moment.
If you had to give us a quick description, what sort of people do this? Are they people who overestimate their own powers, or are they serious people who might actually do this?
We have a complete spectrum, well, a complete spectrum of very odd people, admittedly. We have former and current aerospace engineers who are sort of doing this as their weekend hobby, if you like. People who've worked or still work for NASA and Jet Propulsion Laboratory. We have teams from universities, various people in engineering and electronics industry, and we also have ordinary people, if you like, who have no form of connection with aerospace and who just want to try this.
Let's imagine that your eloquence, which is impressive, I must admit, persuades more people to do this. Is there still time for them to enter?
There is. So the competition runs until September 19th, 2011. So anybody signing up now is certainly going to have to get a move on. But in fact, we've had one team register in the last few days, and the competition is still open right up to the deadline. And if people want to find out more about it, if they log on to the website, which is nprize.com, they can download all of the rules. The entry forms are very simple, 2 pieces of paper, so sign up.
Now, you said earlier on that this all had to be done on a shoestring.
Mm-hmm.
How thin is a shoestring, actually?
It's thinner than that. The cost of the launch, which is everything that leaves the ground and doesn't come back in one piece, has to be under £999 and 99 pence, which is under $2,000.
It's much, much less than a single tile which was used on the shuttle to insulate it from the re-entry heat, which cost, I understand, $10,000 in 1992.
If you went to the European Space Agency or NASA with your £1,000 and said, can you put something into orbit for me, they would probably send you away with a signed photograph of an astronaut and a get well soon card. But it is bizarrely just about feasible, provided you're prepared to do a lot of lateral thinking and a lot of very imaginative scrounging and scavenging. Conventional spaceflight is very expensive, and this challenge is really set to make people start thinking around that problem.
Well, when I was going to sleep last night, I started thinking about how I would go about it. And I asked myself the question, and which I have to ask you as well, is it actually remotely possible? Could you think of a way of doing it?
Part of the inspiration for this challenge goes back to the very early days of spaceflight, when people were just trying to get to the edge of space, just the upper limits of the atmosphere. And back in the early 1950s, people did this using a rather bizarre combination of a high-altitude balloon from which they launched a relatively small and simple and cheap rocket. And this combination, which is called a rockoon, which is a rather ugly word, was enough to get them up to the edges of the atmosphere on a very small budget. and perhaps 60 years later, we ought to be able to do rather better on an equally small budget.
I mean, if I just amplify, the point of doing this, of course, is doing it from a balloon, you get through most of the atmosphere, and therefore you save an enormous amount of energy, not having to rub against the atmosphere on your way up.
Precisely, and this is much more important for a small rocket. If you're a big rocket, your main enemy is gravity, but as the rockets become smaller, although the gravity is still there, you also have a much greater problem with air resistance. Now, a balloon will only get you maybe a third of the way into space, on the order of, say, 30 kilometers. But that 30 kilometers gets you through well over 99% of the atmosphere, so then there's no longer such a penalty on a very small rocket if you launch it from the balloon.
There seems an obvious advantage of using raccoons because of getting rid of the atmosphere. Are all the teams planning to do this?
Well, several of the teams are using raccoons, not all of them, but for example, Cambridge University Spaceflight, now they have a long tradition of high-power amateur rocketry and also high-altitude balloons. And in fact, they've actually just successfully launched their first 2 astronauts, not quite to the edge of space, using a high-altitude balloon. So take a look at this. Now, one of these guys unfortunately seems to have lost his space helmet, but Cambridge University Spaceflight, this was done in collaboration with local schools. It was actually a competition to design a spacesuit suitable for a teddy bear, and they sent these guys on a high-altitude balloon just up, not quite to the edge of space, but up to about 20 or 30 kilometers.
These are Astro Teddies, the first Astro Teddies.
They are, yes. Whether they survive the experience, I don't know. I hope they can hold their breath rather well. Now, we also have several other teams using raccoons. So, for example, Prometheus, a team in the States, they're working on a raccoon system, and they've developed a rather ingenious way to overcome one of the problems in launching from a raccoon, which is that you can't nail anything down. If you launch a rocket from the ground, you have a nice solid launch platform. You can hold the rocket there until everything's working and then launch the rocket when it's stable. You launch from a balloon, you have a problem stabilizing the rocket. So they've developed and tested and built a special launcher for firing rockets from balloons, which spins the rocket up rather like rifling a bullet in a rifle barrel to stabilize it at launch. And several of the other teams are also using raccoon platforms.
There are such obvious advantages in using raccoons. It would be a cue for all the teams to be using this, are they?
No, so quite a lot of the teams are using other approaches. Now, several of them are going for what at first sight would seem to be rather conventional multi-stage rockets, but with some rather ingenious modifications to actually make them possible within the budget. Now, multi-stage rockets are needed because you're penalized by all of the weight that you have to get up into space. So the ideal strategy is to start with a big rocket on the ground to give you that kick off, but then you want to shed as much of that weight as you can on the way up. So even the space shuttle, for example, sheds its solid rocket boosters to lighten the load as you go. So several of the teams are using that approach.
Which is much more conventional. Is there anything really unusually being developed which hasn't been done before on the big scale?
One of the most interesting teams, which was actually one of the first teams to sign up to the N-Prize, is Nebula Aerospace. They're a UK-based team, and they're using an aerospike engine.
But I mean, I have to ask you, because it's a word which I haven't heard before, what aerospike means. So
an aerospike it's effectively a normal rocket engine, but turned inside out.
How do you go about doing this? I mean, what is the advantage of having this inside-out rocket?
Okay, in a normal rocket, you have a combustion chamber where all the exciting stuff happens, the fuel and oxidizer mix, and then the exhaust gases are directed out of the back through a sort of bell-shaped nozzle. Now, the problem with that is that the shape of the nozzle, ideally, depends on the density of the atmosphere you're going through. And that's another reason that you normally need a multi-stage rocket, so that you can switch and change the nozzle as you go up. Now, with an aerospike engine, as you can see in this illustration here from Nebula Aerospace, the exhaust gases are directed onto this sort of spike on the tail of the rocket, which deflects them backwards. But the role of the rocket nozzle is actually performed by the air around it. And because that air density decreases as you go up, it's rather like having a rocket where the nozzle automatically adapts itself to the air pressure.
I mean, if I'm using a bit of science, this is really a way of matching the thrust producing part of the rocket to the atmospheric conditions.
Precisely so, and it means you can have a single rocket engine which will work efficiently over a very wide range of altitudes. Oh, and speaking about bizarre approaches, we do have one team from New Zealand who, for the first stage of their rocket, are going to use a steam rocket.
That sounds very Jules Verne. Is it realistically possible?
It's not quite as crazy as it sounds. Their first stage is actually a large pressure vessel which they fill with water, and they then heat it up to several hundred degrees C. So you've got like a giant tea kettle or a giant boiler, if you like, and when you press the button and open the valve, that extremely superheated water flashes into steam and gives you a very high thrust. It's not quite as efficient as conventional rocket fuel, but on the other hand, water's cheap. They also have the advantage that they can heat up the water before launch on the ground. So it's probably the only rocket that will ever be launched to be powered by mains electricity.
But what sort of satellites are people offering? Have you any idea what designs are being considered?
The rules of the competition specify that not only is the budget ludicrously small, the satellite itself also has to be extremely tiny. So the total weight of the satellite has to be less than 20 grams, and that's about the weight of a couple of pound coins. So the satellite will be minute.
Why do you have to make it quite so small?
The size limit on the satellite, or the weight limit on the satellite, creates challenges of its own. So Sputnik weighed about 80 kilograms, and it just beeped. So the question now, 60 years later, with modern electronics and electromechanical devices, is how much can you actually fit into a satellite which is probably going to be the size of a ping pong ball?
Well, all this seems rather dangerous, if not hazardous.
It actually is rather dangerous. In fact, it's potentially lethal.
So being hazardous, or lethal as you say, doesn't mean there are lots of forms to fill and the rules and the regulations which you have to obey.
Yes and no. Actually just no, to be honest. As far as safety goes, the responsibility lies entirely with the teams. These are grown-ups, they claim to know what they're doing, and the philosophy behind the enterprise is that if you give people some responsibility, they actually do become responsible and look after themselves. So we haven't had anybody losing any fingers yet.
So if I've understood you correctly, by September 2011, the teams will have to have not only their rockets, big firework if you like, as they will have packaged the electronics which allows it to be tracked. They'll have to launch it at a speed which is escape velocity. They have to turn it around to make it orbit. And I understand they have to achieve 9 orbits. Yeah, I think it's really a scientific adventure. It ought to be called an adventure rather than a problem.
Definitely.
And I'm all for adventures. Let's assume you've done all these things. What's the reward?
Well, the budget is small, the prize is not much bigger, the prize is also minute. It's £9,999 and 99 pence. I think this makes it officially the smallest prize for any space competition. But you also get eternal fame and glory. Everybody knows what Sputnik was, everybody knows Yuri Gagarin, the first man in space, everybody knows who Neil Armstrong was. Imagine if you can be the first guy to have launched and tracked his own satellite from his own back garden.
And you've got enough money to do another 10.
Precisely. It's quite a good return on investment, actually, if you succeed.
Do you really, in your heart of heart, think somebody is actually going to win?
I think they will, yes. We have, out of our 24 teams, who includes some very smart people, we have probably half a dozen teams who are in the front running at the moment, and I'm quite optimistic that one of those teams will meet the deadline of September 2011.
Now, it's all happened. You've got your winner. What do you hope will come out of it for the world?
Hopefully no fatalities. I hope a lot of people will have fun. It's very important to have fun in science and engineering, but also innovation and new ideas. If you set somebody a difficult challenge, they'll do it because they'll spend enough money and enough time. If you set somebody an impossible challenge like this one and ask everybody to have a go, then you start getting some truly creative thinking, and that's what I hope will come out of this. Imagine if you could open a newspaper tomorrow and read that a bunch of guys in New Zealand or England or America had launched a satellite from their back garden. What possibilities would that open up? If one person does it, 10 people will do it, 1,000 people will do it.
Paul, a real thank you for putting me in the picture and introducing me into a thought which I find hugely exciting.
Heinz, it's been my pleasure. Thank you.